Hello students, how are you? So today I'm going to discuss on the topic earthquakes. So last class we had discussed about the interior of Earth. So what are all the subsurface layers? What is the internal structure? So we discussed about crust, mantle, core, everything we had discussed in the last class. So in which crust, uh, how much depth the crust is 0 to 100 kilometer, and how much depth is the mantle, and what is the depth of a core, what is the size of a core, everything we discussed in the last class. So especially we need to know what are the layers in between, that is lithosphere, asthenosphere, and the mantle that has been classified into upper mantle and lower mantle, core that is classified into inner core and outer core. A recent study, the yesterday, I saw a research paper. That paper they revealed that the inner core is not a composition of a single element, that is iron or nickel. It's a composition of various elements. That is, we call it as a inner core. So scientists of uh, uh, scientists they discovered the inner core is not made up of a single element. So yesterday, recently the paper was published in a reputed journal. So we don't know what is the inner core and how it formed and what is the exact composition. We don't know, but there is a clue. Always, whenever there is a problem, God will open some doors to seek the solution for that problem. So I believe in that, and scientists and researchers, everyone is believing that all problems are having some solution, some sort of solution. Then why can't we achieve the solution much earlier? That is because it needs some time. That is the way of solving. How? What is the way? In what way we are approaching the problem? All things plays the role to solve a problem. So, for predicting the inner core and the structure of Earth, we had a hint, that is the seismic wave. The earthquake waves originated from the inner structure of the Earth, inner layers of the Earth, which gives the information, enough information about what Earth is, like our inner heart, which reveals what is our character, like our earth, which produces the seismic waves, which energize and which gives the thoughts about the inner structure of the earth. So this is the basic thing, how our inner being reflecting our character, like the waves generated inside the earth, which reflects the entire characteristics of earth. So not only Earth, there are some Mars quakes also, moon quakes also for other planets and other natural satellites also having some sort of quakes in it. That is because of the plate movements and the inner composition. Okay. So these are all the components. So especially I want to say at this point of time, I want to explain about what is a seismic wave and what are all the types of seismic waves, and how we classified these seismic waves. All the things we are going to discuss in this class. So this class will be very interesting to you. So you can post your comments and questions in the chat box so that I can answer your questions, and it will be helpful for you to clear the exams, and it will be one of the important topic in our syllabus. So let us move on to the PowerPoint presentation, and this presentation gives you the enough entire idea about what is a seismic wave, and how the seismic waves are classified, and all the things we are going to discuss it. Okay, so let me start with this earthquakes. What is the relation between the earth plates, volcanoes, and earthquakes? So let me describe what is a tectonic plate. The tectonic plates are made up of rock structures So the crack between these rock structures, we call it as a plates. There are 12 major plates and 54 minor plates out there. So this rock structure, which acts as a complete shield, that is a heat shield, act as a heat shield, that is the tectonic plate. This plate, when it moves due to this movement of this convection current, that disturbs the lower mantle, it disturbs the upper mantle and produces the disturbance on the crust. That is what we call earthquakes. This is what we call earth plates, that is the tectonic plates. Volcanoes. So the volcanoes, which gives the information about the interior structure of the earth. That is the major geological formation and especially the forest and all the natural things that originated from the volcanoes. Can you imagine from a fire how creative material can be obtained? Yes, the volcano, which is at a very high temperature, which erupts from the inner surface and which takes out all the minerals and comes to the onto the surface, that cools down, and the cooled surface, we call it as the igneous rocks. The igneous rocks that produces, that contains a lot of natural resources. That natural resources in turn produces the complete, gives the entire information about, and that is the powerhouse of our minerals. So the entire powerhouse that create forests, that create mining industry to produce a lot of diamonds, gold, everything. So that is the natural resource from a volcano, from fire, high temperature of lava, that produces a lot of natural resources. So and earthquakes. So these are all interrelated. So the earthquake plates and volcanoes, which are interrelated. So let us see one by one. So this is the spreading of plates. So the major plate, we call it as the Pacific plate. So the Pacific plate, in which Mariana Trench, Hawaiian hotspots are there. Then European plate, African plate, Antarctic plate, and South American plate, Nazca plate, North American plates are there. So the major earthquakes are formed in the Ring of Fire region, that is the major disturbance, the boundary region. The major volcanoes are found in the regions of the land surface. That is, some are on the land surface, some are underneath the sea and oceans. Let us look at those map again. So the volcanoes, earthquake plates, three are interrelated. So earthquake and volcanoes are found and formed uh, where the plates meet. Okay, so that junction, we call it as, we can imagine that this is a rig wheels. Students, you might have seen the rig wheels or a gear wheels of a bike or a car engine. You might have seen the rig wheels. Like the rig wheels, when there is a motion of one plate, it disturbs the motion of another plate. So this gear wheels of each plate, that is the Pacific plate, which moves, which just makes the disturbance in the Indian plate, and each and every plate which consequently produces the disturbance and produces the earthquakes. Okay. So evidence of Wigner used to support the theory of continental drift. The Wigner theory which supports that there is a shift in the continental, and it's like a puzzle, and these rocks, how this moves. Geologists explain how the earth plates are moved. That is what we call continental drift. Continental drift. So to see how geologists believe the plates move to go onto the side, that is seafloor spreading animation. Before that, we shall see the layers of earth once again. That is outer crust and mantle, and outer core and inner core. So the crust, mantle, outer core, and inner core. I once again remind you that inner core is solid in nature according to the information given by the seismic waves. Inner core is completely solid in nature. And types of mountains, that is folded mountains, fault block, volcanic, unbarked mountains. So these are the types of mountains formed by these earthquake tectonic plates. Can you imagine these mountains are formed due to the earthquakes? Yes. Yes, it is. This is due to the convergent boundary and divergent boundary and the transform boundary of this earthquakes which produces the mountain. Why Himalayas is so much height, that is 8,000 meters, that is nearly 8 kilometers from the sea level. How is this possible? Yes, it's a convergent boundary that produces the mountains to uh, maintain the steep. Okay, those are all called folded mountains formed when rock layers are squeezed from opposite sides. Okay, then folded mountains, Appalachian Mountains in the eastern United States and the Swiss Alps in Switzerland. It's a very famous mountain, that is the Swiss Alp Mountains. That form two plates collide head on and their edges crumble. That produces the folded mountains. Consist mainly of sedimentary rocks like limestone and shales. Fault block mountains. The major fault, that is San Andreas fault. We had discussed earlier about San Andreas fault. This fault block mountains are due to the earthquake. There is a crack in between these plates. Some of the examples are Sierra in California, Arizona is an example of fault block mountains. Consist of huge blocks of earth crust that have been tilted or pushed up along the fracture line called a fault. So the fracture. So it's not a complete discrimination between one plate to another. It is just a fracture. Okay, created. It's not so created when a plate hits a fault and tips upside down, creating erosion and debris, which is at the base of the mountain. Okay. So volcanic mountain, Namibian Africa. I was seeing Namibian Africa mountain. It is due to the volcanic eruption it produces the formed it from the molten rock and that from the volcanic mountain made up of basalt and rhyolite. Takes place where two of the earth's tectonic plates collide. On above the mountain, one great example is Black Hills in southern Dakota, that is formed when tectonic forces lift the earth's crust into the boat bulge or dome, raising it above its surroundings. Erosion causes peaks and valleys to form. So the convection currents and plate movements, this is the major thing, convection current. What is the convection current? So convection current, for example, let us take an example of two animal cookies represent two of the earth tectonic plates. What happens when it gets heated up? What will happen? The chocolate pudding represents the earth's mantle. The heat source beneath the pot created the convection cells into chocolate pudding. Think of a cookie on the left has South America and cookie on the right is Africa. Over a time, they have moved apart. That is because of this heat and up. That is mainly due to the convection current of this liquid. So the convection current in the Earth's mantle are what drive the plate motions. Okay. So the convection current are driven by the simple fact that hot things and rise while cool things fall. So the convection current in the magma moves the Earth's crust. So the convection current, which produces a lot of heat radiations, and it produces the lava and the high temperature magma to move to the Earth crust. So the epicenter, the point on the surface of the Earth that is right above the focus of an earthquake, we call it as the epicenter. This is the focus or a hypocenter that where the earthquake originates. So the seismic stations can observe and can sense the earthquakes instantly and produce the data that will be useful for warning to the public. And P waves and S waves, the primary waves, are the first one to emanate from the source of an earthquake. Are not far less destructive than S waves, but unfortunately, it's of a very small time between P waves and S waves. Though it originates first to the station P waves, we cannot able to escape it from S waves as there is very short time in between. So the S waves, we call it as a secondary waves, primary and secondary waves. P waves we call as a primary wave, and the S wave or deadly waves, high energy waves of earthquake travel at half the speed of P waves. So these are some websites useful for this. How do we measure the intensity of earthquakes? That is, seismograph measures the magnitude, how much strength is the earthquake. This is the seismograph records, energy waves of the earth. This is a seismic seismograph, that is the primary wave and the secondary wave. So the scale we are using it, Mercalli scale, and Richter scale is the famous scale we are using it. For example, earthquake magnitude is less than 3.5. It's generally not felt, and 3.5 to 5.4 rarely cause damage. Under 6, slight damage to well-designed buildings. 6.1 to 6.9 restricted to about 100 km across, and 7 to 7.9 major earthquakes, serious damage over large areas, and 8 or greater, that is the greatest disaster, that is a great earthquakes. It will destroy the entire buildings and it will shake each and every pot on the surface of earth. So definitely no one will escape if the magnitude is greater than 8. Okay. So each number is 10x stronger than the previous number. How much stronger is 3 than 1? That is 100 times. How much stronger than 8 than 1 is 10,000 times, right? The number in the scientific notation, that is 10 to the power 6. Why is the Richter scale more accurate than Mercalli scale? That is, it's subjective based on the mathematical measurements. But Mercalli scale is subjective and based on people's perception and experience. So we are using the Richter scale. So the Richter scale magnitude, number of earthquakes measured between 1 to 3.9 is 900,000 plus. Then 4 to 4.9, that is 6,200. 5 to 5.9, 800. And 6 to 6.9, 226. And 7 to 7.9, 18. And 8 to 8.9, less than 2. Then next thing is this is the San Francisco earthquake on 1906. How much it brings the it brought the greater damage to the buildings. That is, it's a museum. And this is Alaska earthquakes in 1964. It destroyed the entire building, and all the apartments fell apart. So tsunami waves may cause due to the earthquakes hit under the ocean. So 30-inch wall of water that creates a tsunami. Types of volcanoes are there. That is a composite, cinder, cone, shield. So I will move fast. That is, this kind of types of volcano are there. The largest single mountain in the world, and this is all about earthquakes. So, students, today we saw a lot of things, and especially in terms of earthquakes. What are the types of earthquakes? That is a primary and secondary waves. Today we studied primary waves and secondary waves. Primary waves, which originate first at the seismograph station, and the secondary waves, that is the surface waves, which reaches the destination at next to the primary. Okay, so the earthquakes, we classified the earthquakes based on the magnitude and how much magnitude is there, and based on the magnitude we are concluding that how much disaster it can bring. So it is very difficult to predict earthquakes. There are some notable points to predict earthquakes. That is, if you want to predict earthquakes, we need to bring out some useful information related to earthquakes. For example, one thing is there any relation between the magnetic field of Earth and the earthquakes? Second one, if there is any solar disturbance and solar magnetic field, that is, we call it as a solar coronal mass ejections or solar activity cycle. So, is there any impact of solar activity to the earthquakes? We need to bring out some information or some statistical data, and we need to plot it, and we need to do some research on this area. The third one, we need to understand the internal structure of Earth thoroughly. Unless we study this interior structure, it's very difficult to understand what is earthquakes and how to predict earthquakes. It's very, very difficult to predict earthquakes. We need to get more information about the interior structure of Earth. For example, geological formations are completely complex. You are standing on the place, the geological formation is like a sedimentary, igneous, and metamorphic rocks may be found inside, but after 10 feet away, there will be a complete aquifer content may be there underneath. So we don't know what will be there underneath. So we need to but based on our advanced technological instruments and machineries, we can't drill beyond 11.9 to 12 kilometers. But imagine the radius of Earth is around 6,000 kilometers. So it is very difficult to dig and find out what is inside. So we can use some of the techniques like electrical methods, electromagnetic method, and some seismic method, refraction, reflection studies, so that we can understand what is inside the earth using some seismic waves. So this is an open forum, and this is an open book to all, so as to save our future and to also save our society, our humankind. More researchers should voluntarily contribute some research in this area, that is the earthquakes, and to study seismic waves so as to save a lot of people. See how many earthquakes that have been formed between 1 to 3.9 magnitude, that is 900,000 earthquakes are forming. So every day, so every year, 900,000 earthquakes are forming, and it's disturbing our earth. Every day, earthquakes are happening here and there. So, in order to predict and in order to save our environment and save our future, our future generation, we need to predict earthquake accurately, and we need to make things very clearly so that we can understand and we can understand the nature. But my own suggestion and my own point of view is, unless you are attached with the nature, you will never predict. You can never ever understand nature. You should attach. You should understand nature only if you are attached to the nature. It is not artificial intelligence, or it is not a machine learning that can able to predict earthquakes. Only you should know, and you should understand nature. Then only you can predict the earthquakes. So that is all my wish. I encourage all the young researchers and students to do volunteer, volunteer, voluntarily contribute to this research, and I welcome more number of students to do research in this area, earthquakes, so as to save our future, our generation, and our mother nature. Okay, that's all for today. You can post your comments and suggestions in the chat box. And one more thing, if you have any questions or queries, you can post it. I will immediately reply, or else I will answer your queries as soon as possible. Okay, so this is what we discussed today, and just I want to summarize a very quick summary. I will make it. So that is, we saw what is a earthquake, and what is a P wave, and what is this S wave, and how it affects buildings, and what is the magnitude, what is the scale, all the things we discussed. And next class is much more interesting. That is seismic waves, how it propagates. So how it propagates into the liquid, how it propagates into the solid, everything we will be discussing in the next class. So don't miss out my class. So this earthquakes, I will disturb you through these earthquakes. Okay. So that's all for today. Thank you so much. Thanks. Thank you for your cooperation, for being with me at this point of time. All the best. Have a nice day. Thank you.